So we are starting proofs. Geometric and algebraic is kind of in here some places. So every time I teach this lesson, I try to find a better way to make it a little bit easier, to put all of the things exactly where it needs to be to help you. So as I was teaching this to my other classes, I thought that this chart would help you in knowing what to do in all these scenarios. So you're going to see a lot of familiar things from chapter 1. What is wrong with y'all? Come on, we got this. Okay, so here we go. If you see something that says Q is between P and R, like this line right here. If Q is between, it doesn't say in the middle, between, so draw this on your paper. If Q is between P and R, here is what you can say about this scenario. Remember this, P, Q plus Q, R equals, remember that? Do y'all remember what it's called? It's 3 words. It's 3 words. The first word starts with an S. What is this? What is this? What kind of line? Segment. What are we doing to these segments? Adding them. Segment. Addition. Postulate. Oh, were you? Is it up there? There it is. Yes, that's what we call it. Okay, it's called segment, addition, postulate. A piece of the segment plus the other piece of the segment equals the whole segment. Okay? That is whenever Q is between. Now, if Q is the midpoint, that means if we have this line, P's over here, Q is in the middle, that means that these pieces are congruent. So draw that line. If Q is the middle of PR, then you can say PQ is congruent to QR. That is called the definition. This is how I shorten the word definition. Definition of midpoint. Okay, if two things are congruent, we know they're the same, but we don't know anything about them being equal. Okay, so if they're the same, then we know they're the same, but we don't know how high they are, how tall they are, how, like, whatever the number is. So if it says that these two segments are congruent, we have to go through a process to show that they are equal as well. When you go through this, it means you can plug in numbers. So if you're plugging in numbers, you have to go through this. The reasoning behind it is called definition of congruency. I'm going to explain more about that in just a minute. So if it's congruent, we have to show that it's equal. Okay, right here, we've been using this property lately in 2.6. It was on that chart from 2.6. If AB is congruent to CD and CD is congruent to EF, can't I just say that AB is congruent to EF? What property is that? I heard it. Good. Transitive. It was quiet, but I heard it. So basically, it's cutting out CD. It's cutting out the middleman. Okay, we're going to fill in just the next two. Then we're going to wait for another day for the rest of them. So these two are talking about angles. So let's draw an angle like this and put a line going through the two angles. Label it P, Q, R, S. So P's over here, Q's over here, R, S. Just like we have segment addition postulate, we can have angle addition postulate. So if this little angle, if I take this angle and I add it to this angle, I will get the whole angle. Okay, so this is how we write it. Angle PQR. This one right here, from P to Q to R. Remember, when we're naming an angle, the vertex always goes in the middle. So PQR plus, what's the name of this angle? SQR of this one. Okay, so angle, oh man, I put Q first. Make it into an R. I'm just going to white it out. Angle RQS. When I add those two together, it equals PQS. It equals that whole thing. So you can add two angles, and it will equal the whole angle. It's called angle addition postulate. So you have segment addition and you have angle addition. Alright, last one. Then we're going to start proving some stuff. Okay, make another angle. Label it C, A, D, and then B is in the middle. Stay with me, guys. Stay with me. This will pay off. It'll be easier when you're doing it here. Okay, so what does the word bisect mean? What's bisect mean? Cuts it in half. So, if you have this ray, AB, and it bisects these whole things, CAD, then let's call this angle 1 and 2 to make it easier. Angle 1 and 2. Then, angle 1 is congruent to angle 2. So if something bisects, then this angle 1 is congruent to angle 2. And the reasoning behind it is called definition of angle bisector. Alright, let's look at your note part.
Hold up.
Oh, hold up. Okay, let's look at this part. Now, some of this is a quick review of what we just did. So look at number 1. What does that look like? Use your chart, so keep this chart right beside you. Use it as a reference. What's number 1? See it? Segment addition. Because look, this XR plus RW is equal to XW. So this is called segment addition. If you want to shorten segment addition postulate, you cannot put SAP because I want you to know what the words are. If you just put SAP, you'll just write SAP all the time. If you're going to shorten it, you need to put seg, add, post. I want you to know what you're writing, not just SAP. Okay? So just like we have segment addition postulate, what's this one showing? Angle. This little angle plus this little angle equals the whole angle. If you're going to shorten it, you need to put ang. Now, number 3 is starting to look like a little proof. Okay, so we're going to start, just you see down here, just like we had, I'm going back up, chill out. Just like we had those algebraic proofs, this is what our geometric proofs are going to look like. So, number 3, it told you that R is the midpoint of QS. Therefore, we can say QR is congruent to RS. But if we use midpoint, look over here, if we use midpoint, what's that called? Definition of midpoint. So that's what you have to write right here. So you write definition of midpoint. The reason you can write this is because of that definition. 4, it says that BD bisects ABC. Well, therefore, angle 1 is equal to angle 2. What's the reason I can write that? What's it called? Right. Okay, we're going to start to get a little bit harder. Okay, remember how we drew those 2 columns for our proofs? This is kind of set up the same way. So I want it to look closer to what we've been doing. So draw a line here, and then draw a line here. This is your statement over here. And then this is your reason. So it looks like a 2-column algebraic proof. Now, you always start off, just like we did before, with whatever you're given. So here we're given that AB is 12 and BC is 9. What is this thing? What's that look like? Courtney? See, it's AB plus BC equals AC. So 2 is, the reason they wrote that is because of seg add post. Segment addition postulate. Okay, now we're going to be using some of those properties from 2.6. You dancing? What'd you do? Oh. What happened between 2 and 3? Substitution. You see, they plugged it in. Plug it in, plug it in. So whenever you plug it in, that's substitution. So that's number 3. You should know the rest. Yes, you should. What's it called when we... But remember, oh, I heard it. Jojo, was that you? What'd you say? Combine like terms. Good job. That's how we got to 21. Because they combine like terms. 12 plus 9. Now, what happened from 4 to 5? They switched, which you know a property. What's it called? Symmetric. Good. See, this isn't too bad yet, is it? Straight? Is it straight or scrape? Scrape. It's scrape. Like I go scrape on the street with my homies and direct messages. I'm just saying all the things that people have made fun of me for. Okay, here's number 6. I'm going to set up my columns. This is my statement, so you can write S. This is the reason, so you can write R. I want you to try to do number 6. Go.
What?
Maybe if you would have gotten off that side, we'll center you in the learning. I saw it. Because I got negative 3.5 contacts in it. I can see a little bit.
Is that a real thing? That's not
I'm not hearing from call. Negative 3.5 on both sides.
I'm not that good.
Is that?
Really?
Yeah.
I wear contacts.
Still take money. Y'all got this. Come on, you got it. You got this. You take it on. Alright. What's 2? 2. Carson Burks, what's 2? What's 2? Get off that phone. Pay attention.
I feel like I know it.
Savannah.
You know it.
Yeah, good. Seg.
What the?
Add.
All about it.
Maybe if you had gotten off your phone, you could have said it sooner. Seg, add, post. Segment, addition, postulate. Yes. Next one. What is it? Substitution. Good. And then how do I get from 3 to 4? Subtraction. This isn't as bad as I made it out to be, huh? Okay, just keep holding on. I'm just kidding. I'm not going to try to make you miserable. I'm just going to try to make you learn. Okay, good. Can I take this down? Carson, could you write this down? Segment, addition, postulate, substitution, subtraction. Okay, now, 7 and 8 is where you start having to think because it gets a little weird. So, earlier on this thing, I told you about the definition of congruency, going from congruent to equals. So that's what 7 and 8 is showing you. You can go backwards and forwards. So if you start with a congruent symbol, and then they drop it, that's reasoning is definition of congruency. If you want to shorten that, you can put definition of, and then a congruent symbol. Okay? Just like we took away the congruent symbol and put an equal, if you have an equal and you add a congruent symbol back, it's called the same exact thing. So, here's the reason that you need to use this. Sometimes I told you we have to do it to plug in numbers. However, your ending proof, what you have to prove, might have a congruent symbol. So you might use this twice in one proof. Stay tuned. We'll go through that later. Okay, number 9. B is the midpoint, which means AB is congruent to BC, which is what they wrote. What is the reasoning for this? Definition of? No. What's this key word right here? Midpoint. If it says midpoint, you're probably going to use definition of midpoint. Okay? Now, what happened? What changed between 2 and 3? They dropped it. They dropped the congruent symbol. So that is definition of congruency. Y'all with me? Okay, now 4, they gave you the fact that AB is equal to 5. And then on step 5, they plugged it in. What's that called? Plug it in, plug it in. Substitution, right? What happened from 5 to 6? Symmetric. Are y'all following along? Did I make it seem worse than it actually is?
Yes.
Good. I like doing that. Don't you like that when that happens? They're like, you're going to owe $400, and then you get there, and they're like, you only owe $200. And you're like, oh, okay. That usually never happens, though. It's usually like, you owe $50, and then you get there, it's like, oh, you owe $250. I'm like, what? Like Verizon just cannot get our cell phone bills right. I don't know what is happening to them. They need to get it together. Okay, now you have to write your own proofs. I'm gonna do one with you, and then you're gonna finish 12 and 13 for homework, and then you're done. Let me rephrase. I'm gonna do 11 with you. You're gonna do 12 and 13 for classwork, and then you'll be done. Okay? So let's do it. If you write big, you might want to grab a sheet of paper. Oh my gosh. Jacob, you get him. Call him out. Okay, here we go. Let's draw our columns. So we have statement. We have reason. How many things are we given? 2. I don't mind if you write those on the same line. Okay, I know your activity yesterday broke it into 2 separate ones, but I really don't mind if you write AB equals 7 and AC equals 15. I don't mind. What's the reasoning behind that? Thank you. Okay. Now, they told me that AB is equal to 7, this little piece. Then they said that AC is equal to 15. I have to prove that this is equal to 8. Well, most of you in here are smart enough to know that 7 plus 8 is 15. But we can't just do that. We have to show it. So which one of these are we going to use? No. Segment, addition, postulate. Yep. Didn't say anything about midpoint. If it didn't say anything about midpoint, I can't use midpoint. Okay? So, let's write it out. AB plus BC equals AC. Whoops, I kind of slanted. The reasoning for that is seg, add, post. What comes next? Good, I heard you. Is that you, Asia? Good job. Substitution. We need to plug it in, plug it in. AB is equal to 7. Don't plug in BC. You don't know BC yet. That's to come. So keep BC. What's AC equal to? 15. Very nice. So step 4 is subtraction. So BC is equal to what? Is that what we wanted?
Yeah.
Dunzo. With that one. Okay, I'm going to help you get started with 12. Then you're going to finish it and finish 13, and you can pack up. Okay. Here we go. 12. What does it say on 12? What are you given? B is the what? Oh, what do you think we're going to use? Okay, so write what you're given. Do I have to write all 3 of those? Yes. B is the midpoint of AC. AB is equal to 4x minus 3. And BC is equal to 11. Cardell, I think someone's at the door. Did I just hear something? Okay, that's given. That's what I was given. Now, I also see that there's a line beside it. It says A, B's in the middle, and C. So if B is the midpoint, B is the midpoint, so over here, if there's a midpoint, you need to write that they are congruent. So, what's congruent to what? This is by the definition of midpoint. Now, are we about to plug in numbers? So, we have to drop the congruency symbol. We can't plug in numbers that are equal to something when there's still a congruency sign. So you have to go through AB equals BC, which is the definition of good. Why are you backing up? What's step 4? You have 2 steps to finish. Then I want you to do number 13. When you're done, you may pass it.